Good evening, everyone. Welcome back to another episode of vBrownBag. We are going to continue our series on NSX T tonight with Britton Johnson. He's going to be talking about NSX T security and distributed firewall. But before he does, a couple quick housekeeping notes. This is an interactive show, so those of you who are watching live, please engage with us either with the Q&A box here on Zoom or via Twitter using the hashtag vBrownBag. Also a reminder that we have multiple shows. Check out the times here that we have listed. If you want to join any of our other ones, you can also go to vbrownbag.com/brownbags to check them out. If you missed any of our previous shows, we always post them up within a day or two on our YouTube channel. Pretty easy to find on YouTube. vBrownBag there as well. I'm your host, Ken Nalbone, once again for the series, and I'm going to hand it over to our excellent guest, VMware's own Britton Johnson. Britton, let me pass it to you. All right. Go ahead and share your screen.
Set up here. One. All right, you got it?
We got it.
All right, welcome everybody. Thanks for joining episode 3, part 3 in our minimum 4-part series of NSX T vBrownBags. Again, I am Britton Johnson. I am a senior solutions engineer in the NSBU, working in the healthcare sector for VMware. I am a vExpert. I am in the vExpert NSX program and just got re-upped in that for another year. Thank you to the vExpert crew for that. And that's just generally who I am. And that's what I do for VMware. So if you missed any of the first couple episodes we did, check again back on the vBrownBag YouTube channel. We went through kind of a recap. We went through the general overview of what NSX is and does and all the good things it can do for you. And then last week we did a deep diver into switching and routing and how NSX handles that. And today we're going to take a look at how we look at security in a software-defined model with microsegmentation, distributed firewalling. We'll go through some of the overview and architecture of that, policy grouping, some of those kind of options and methodology for how to collect things together in policies. We'll do a little bit of troubleshooting, and that's where I'm going to cheat a little bit and go back over to another tool we have, which is vRealize Network Insight. We'll take a look at that for a bit. And then we will, after that stuff, I'm going to dive into some, additional advanced firewalling functions with, FQDN, URL whitelisting, so identity firewall, introspection services, which is kind of key, especially for VDI and keeping endpoints secure. And try to, if I don't completely go over on time, because I have a lot of stuff to get through tonight, we'll take a look at how we handle bare metal security. So it's going to be a lot. Hopefully I don't get racing too fast, and hopefully things kind of come across, as clear as possible. But there is so much to go through when we're talking about, NSX as a security platform. There's just a lot that it can do. And there's really, like with most things in technology, there's 50 ways to do anything, right? So I'm going to try to give you 2 of those 50 tonight. So some resources. One of the key things that we'll talk about is, partner integration tools and things. So NSX, we do a lot of our own internal security, but a lot of customers like to use, partner integrations from third-party security vendors, like Trend Micros and Palo Alto and Checkpoint and, all these various vendors who do security products on their own. And they are partners of VMware. And so we have integration capabilities into NSX through them. So one of the key resources I wanted to point up today is, we have a resource compatibility matrix. So you can search through and basically say, this is the version of NSX that I have deployed. What vendors are compatible with this, and we'll show you, which of their products, plug into NSX and what they can deliver through that, just to make sure that, the version that you have deployed is serviceable by the version of product that you're implementing from these third-party vendors. So, very key to take a look at that stuff. If you want to get through some of this stuff yourself, the Lightning Lab out on Hands On Labs, hol.vmware.com. Really cool and fun to go through that one. It's only 15 minutes, just to kind of go through some, basic microsegmentation firewalling practices. The Hands-On Labs right now are, and as always, are a lot of fun to get through. Really good way to kind of get your feet wet in taking a look at how the product works without actually having to go through the pain of deploying your own home lab. So take a look at that. All right, let's get this party started, Ken.
Please do, yes.
All right. So, overview and architecture. So for those playing along and watching this whole series, you may have, first of all, I wanted to say thank you. This has been a lot of work, but it's been good. So then second, you've seen this slide before. This is the one of our standard architecture slides that show, how we kind of produce and secure all traffic and things. But what I wanted to add on top of this thing this time is sort of how we apply security to all this stuff. And that's the next piece of this page where, we have this thing that lays on top of all of those, connected workloads. Again, be they, virtual machines, containers, bare metal servers, all of it, is this thing called the distributed firewall. And this is really how we can extend security, from end to end, with the distributed firewall and provide security wherever your workloads live. And it's this thing that just it's embedded in all of our services. It's embedded in all the nodes, and it provides, a security framework that, we can lay policies on top of and just really build it into your environment so that you're not just bolting on all these extra services. That to me is really the big differentiation point of how we handle security, is this whole concept and notion of it being built into the product as opposed to bolted on after the fact. And how we do that is, through stateful services inside of the distributed firewall, and there's option to have stateless services as well. We have, again, still support for multiple hypervisors with ESXi and KVM. The multi-workload virtual machine, containers, bare metal, on-prem and public cloud, and sneak peek into next 2 weeks from now. Number 4 episode of this vBrownBag is the NSX Cloud and HCX migration. So that'll be sort of a nice way to wrap this up, and we'll take a look at how we can extend security out to public clouds with NSX Cloud and really get this stuff spread everywhere. And we're gonna, the other piece of this is that I like to point out is, all this stuff on top of the distributed firewall is grouped together, and we'll look at how we work on those policies in a bit. So this is a high-level overview of the management control plane and data plane and how it relates to the distributed firewall. You configure your policies at the NSX manager level, which performs, validation, stores your firewall configuration elements such as rules, so the different sections, the different grouping objects, and then that policy gets pushed down to the control plane cluster. The control plane cluster, takes the rules you've configured and converts them into objects used, in your rule definition, such as, a logical switch or groups into IP addresses or MAC addresses or, any of the various grouping methodologies, which we'll get into in a bit. And that policy, gets pushed then down into the hypervisor. And what we want to show with this is again, how, the configuration push is done from the management plane through the central control plane to the end transport node or hypervisor. And then at the bottom here, you see the 3 hypervisors. The one on the left is, they basically, we're kind of showing how it's, could be either or. Could be ESX, could be KVM. You could also interchange some bare metal stuff in here. So, is really how we separate this distributed data plane from the control plane, so that the two are not necessarily in the way of each other.
By the way, thank you for the legend at the bottom of that slide, clearing up what those acronyms are. I was getting a bit confused.
Ah, yes. Zoom in on that one later.
We'll double click on it.
Yeah. Double click on it. All right. The data plane. The NSX T transport nodes, make a distributed data plane with the distributed firewall enforcement done at the hypervisor kernel level. So this is probably the big, major differentiation point that NSX has over, most other security, virtualized security solutions. We're baked right into the hypervisor. It's part of the kernel. We can run, line rate in the CPU. I mean, it runs closer to the workload and more. I'm starting to not like the term microsegmentation all that much, but it enables that granular ability to get to a zero trust network, but really more seamlessly than any other solution that I have seen. And I'm personally, Ken, keep me honest here. I'm personally trying to stop using the term microsegmentation a little bit more and talk more about zero trust, because in a security context, that usually plays a little bit better.
I think zero trust certainly plays well, but microsegmentation was such a clever marketing term. You can't let it go now, can you?
Yeah, but it's been co-opted by so many other vendors, so
I suppose.
And everybody has a different, a bit of a different take on what microsegmentation means, and so it kind of lost its meaning.
Oh, that happens with anything over time, I guess.
Right. It's like, it's the Kleenex conundrum. Is it a tissue or is it a Kleenex?
Well, it's not a Band-Aid.
That's right. So, all right, I've completely lost my train of thought now, so I'm going to push on.
You're welcome for that.
All right. On our transport nodes, once the local control plane has the policy configuration from the central control plane, or the CCP, it pushes the firewall policy and rules to the data plane for each of the virtual network interfaces, with the applied to field in the rule or the section which defines the scope of enforcement. The local control plane makes sure that only relevant distributed firewall rules are programmed on relevant virtual NICs instead of every rule everywhere, which is not the optimal use of hypervisor resources. So that's kind of a key statement right there. We're not trying to just do this blanket thing of wherever the workload is, just apply that rule everywhere. We're going to fine tune it down to exactly where it needs to be on the interface that's actually processing the workload at that time. Because we don't need a host that doesn't even have part of that workload to have a rule on it that doesn't pertain to a workload that's nowhere near it. Taking up valuable resource on that node when it could be doing something else. It's sort of the idea of the government that governs closest governs best. So briefly looking at the KVM side of things, on the KVM, the NSX agent is the primary LCP component. It receives the distributed firewall configuration from the central control plane, same as an ESXi node. The NSX agent has a distributed firewall wiring module as a component. And that obviously, again, the way this is kind of worded bothers me a little bit, because it's not wiring, it's all software. Early days of NSX, they used to be called virtual wires. They weren't all called logical switches. So a bit of history there. So this is used to generate open flow flows based on the firewall rules that were pushed from the CCP. Stateless filtering is implemented through the OVS daemon, which is part of the Open vSwitch distributions. And it implements the wiring implementation it's received from the local control plane in the form of open flows. And then statistics are exported through the management plane agent directly back to the NSX manager. So again, I mean, I try not to spend too much time on KVM because I know it's not all that readily out there, but it does happen. And it will come up on the exam as well. And again, I think I forgot to mention this at the outset, this is mostly going to be based around NSX T 2.4, 2.5. We probably will have to schedule a NSX T 3.0 update session now that it's GA. All right, so here's a look at the distributed firewall policy lookup and flow table and rule table. So, we have a packet, and, the packet does a lookup on the connection table to determine if an entry for the flow already exists. So we hit the distributed firewall, and here it hits the flow table lookup, first to see if anything's there. If the flow is not found, we flow out to the rule table. We do a top-down order for our 5-tuple match. Flow on the packet hits rule 2, which is allow. So the packet is sent out to the destination. So after that, because the action is set to allow for flow, a new entry gets created inside the connection tracker table, and that packet is, once it transmitted out. Subsequent packets are then processed in an order where a lookup gets performed in the connection tracker table to see if an entry for the flow already exists. And then any entry for flow 3 that exists in the connection tracker table, the packet is just straight up transmitted out. It just kind of remembers you're a valid flow. I've seen you before, be about your merry way.
I'm definitely going to have to come back and watch the video on this part. Very useful information. I'm not going to retain all of it.
Yeah, well, me neither. I'm doing my best. Okay. So the other kind of piece of this is, deploying NSX with a network overlay, where everything happens in the overlay. Shockingly enough, not every customer wants to do that. So we give customers options, and we can still do distributed firewalls, even if you're deploying, VLAN-backed, virtual networks, where the VLANs still need to be created, on the underlying network. The big difference here is, you still have to add transport nodes to the VLAN back transport zones. The things that aren't required are logical routers, edge nodes, or even TEPs on the hypervisor transport nodes. But you still do have to move away from the vSphere standard switch and the vSphere distributed switch in 2.4 and 2.5. This is a side note here. This is probably the biggest change with vSphere 7 and NSX T 3.0 is we now kind of support, again, the vSphere distributed switch version 7. So they kind of took this thing and they call it now the converged vSwitch, where the vSphere has control over the virtual distributed switch in NSX, and at the same time NSX can also control it. So it's kind of a shared resource of sorts, is my understanding. So we'll learn a lot more about that as we dive deeper into NSX 3.0 in the coming months.
Sounds like everything old is new again.
Pretty much. Okay. So for IP discovery, the NSX distributed firewall and edge firewalls have a dependency on virtual machine to IP discovery, which is used to translate objects to an IP address before rules are pushed into the data path. This is mainly required when the policy is defined using grouped objects. The VM to IP table is maintained by NSXT controllers and populated by IP discovery mechanism. The IP discovery used as a central mechanism to ascertain the IP address of a VM, obviously. By default, this is done using either DHCP or ARP snooping. In VM tools is the other mechanism used within ESXi hosts, which is optional. These discovered VM to IP can be overridden by manual input if needed. Multiple IP addresses are possible on a single virtual NIC as well. The IP and MAC addresses learned are added to the VM IP table that is used internally by NSX T for spoof guard and ARP suppression, in addition to firewall object to IP translation. That felt like a mouthful.
It sounded like a mouthful. Congratulations on getting it all out.
Yeah. Whew. IPv6. And I'm just now recalling that somebody asked if IPv6 was supported for TEPs, and I still forgot to look that one up, Ken.
Well, we'll just get to it later then, right?
Yeah, I'm going to have to. In general, though, IPv6 is supported. IPv6 discovery is required, however, so we have to have neighborhood discovery, VMware tools, and it's configured in the IP discovery profile. By default, these things are disabled in the discovery just in the default discovery profile. In the rule settings, you say where the rule is applied to IPv6 as well, or instead of IPv4. So you kind of have to go through these various setting pages to configure and turn on IPv6 so that you can build rules around it. Another good thing to read up on and check in the design guide, like we talked about last time. No questions so far, I see.
None yet. Keep on rolling. We're doing good. Great.
All right.
And good.
Grouping,
good and great.
Good and great, yes. We're grouping methodology and consumption. So we can collect the virtual machine inventory two ways, either directly from the nodes under management or through nodes in a vCenter. Collecting this inventory to facilitate automating host preparation on a vCenter cluster by cluster basis supports up to 16 vCenters. Microsegmentation and collecting VM inventory to facilitate microsegmentation based on VM names and VM tags, or collecting a public cloud inventory for cross-cloud microsegmentation, again, can be based on VM names or VM tags. Tagging is probably the most efficient way of knowing your workloads are protected and making sure that things are where they need to be. Implementing a good, strong security tagging methodology is what we at VMware was likened to some of today's best security practices. So definitely talk to your friendly local VMware resource about tagging policies and tagging methodologies. If you're coming from the traditional firewalling world of everything has an IP address, so just base all your security around IP addresses. It's not. It works, in this type of a firewalling methodology, but it doesn't work as well as a tagging strategy can. Because in a virtual world, and especially in DR scenarios, IP addresses change.
But tags are forever.
That's the idea.
So we have a question that just came in. Everyone was asking, for someone that doesn't have an in-depth networking and security background, what would you suggest for someone with more of a VMware background to use to grasp some of these concepts?
So you're basically me. I did not start out as a networking person. I was a vSphere admin who converted myself into an NSX admin, because really, at the end of the day, it's all virtualization. So you ultimately, like, if you're a hands-on gearhead learner like me, you just got to get down in there and do it. That's my one piece of advice for people who if you feel like this stuff is scary, it's really not. In a lot of ways, it's like teammate of mine, Paul Mancuso, he likes to say, the things in NSX T, we've kind of made them so that, if you have a Cisco CCNA level, of knowledge, you can handle NSX, no problem. So. And definitely reach out to the community. We're all here to help each other. grouping constructs. So we can group things in a variety of ways in NSX T. So we do, static members, IPs max, criteria based, and then the identity based firewall. So for statics members, we're looking at things like segments, segment ports, groups, virtual network interfaces, virtual machines. IP MAC, of course, is IPs or MACs. The criteria based one, this is the interesting one where we do logical ports and switches and virtual machines, but these can all be tags. You can base things, as part of, you can create tags based on these things, I should say. And then there's also things like virtual machine OS name and type, or the virtual machine computer name. The virtual machine OS one is interesting because, say you are a company who has, Windows 2003 virtual machines still in existence and still doing things for some crazy reason, which does happen. If you wanted to build, a policy, for all of your, legacy operating system workloads that are still in production, all these years later, you can, turn on a couple of policies and say, hey, any machine that has this operating system, don't let it do X. Don't let it talk to this network. Don't let it go to the internet. And, within a few clicks, you've, basically siloed off all of that, legacy security hole in your environment from being able to do really any damage. The identity-based firewalling, we'll look at this a little bit later, is really key use case here is for end user compute. So for Microsoft Remote Desktop Session Hosts, or RDSH, they call it now, which I still prefer the old name of terminal server for that, but that's just me. AD groups in terms for just VDI in general, be it Citrix or our own VMware Horizon. We support pretty much all of them. And it's, it's identity-based firewalling. Again, we'll get into it. I think it's one of the more powerful tools that NSX has to offer enterprises today. So additional constructs here, again, you want to be consistent. Any object created in the advanced UI, as we looked at before, is not going to be visible in the simplified UI. So always try to be creating objects in the simplified UI. Dynamic exclusions are not supported. And these, the VAPs, resource pools, data centers, those group membership criteria are not supported. So choosing policies and methodology, grouping methodologies, you all, of course, this kind of stuff is probably done in most enterprise groups. It's probably done in a group setting. You want to choose the policy and grouping methodology before beginning the process, and that'll provide clear direction on how to tackle challenges along the way. A networking security TAM friend of mine named Ben, he once gave an NSX presentation to our local VMUG entitled "You Can't Do It Alone," and he was talking a lot about this of if you're deploying NSX in an enterprise environment, you really can't just be an NSX god, as it were, and just say this is how we're going to do things in this environment. You have to do this, and networking and security and IT in general as a team sport. And you got to have everybody in the same boat. Otherwise, you're just asking for trouble. And so that's where you're going to have to work. And this is one of the other I think benefits of NSX as a product as well, is it brings teams together. It brings the compute guys in the room. It brings the networking guys in the room. It brings the security guys in the room, guys and gals. It brings us all together and makes everybody kind of communicate. And we've seen this countless times where our customers go to look at network policies and see how that affects things, and all of a sudden they're having to talk to the storage people who they haven't ever had to interact with before. And so it's creating a lot of communication in organizations that wasn't there before, and it makes for organizations that can do things a lot faster in some cases. So looking at network based approach, this is the traditional approach of grouping things based on either layer 2 or layer 3 elements. Grouping can be based on the MAC address or IP address, or a combination of both. NSX supports the approach of grouping these objects this way, but the security team, in these kind of areas needs to be aware of networking infrastructure to deploy network-based policies. So, and it's, of course, the other reason we kind of try to encourage people to go towards tags and, other different ways of building security policies is the security rule sprawl, where you have just this massive list of rules, is real high probability of that happening when you use a network-based approach. So in the infrastructure approach, grouping is based on infrastructure like logical switches, logical ports. XVM is connected to X logical switch, and security teams need to work closely with network administration team to understand how those virtual connections are made and their boundaries that they are, where the boundaries exist. On the application side, in this approach, grouping here is based on application type. So a VM tagged as web servers or production zone or something like that. And application security gives those different things, give them the application different security postures. The advantage of the approach is, the security posture of the application is not tied to either network or infrastructure constructs. Security policies can move with the application irrespective of network or infrastructure boundaries. And policies can be, templated and reusable across instances. The security team needs to be aware of the application, of only the application needed to be secured based on these policies. It's a lot more flexible of a way to build in and group things together in your environment. So I don't know if you can see this. This is sort of a little animated GIF that kind of rolls through the different screens for how we have these, predefined categories in the distributed firewall.
It's coming through very well.
So if you configure, this, you configure the rule under the relevant category and the all rules. Rules are processed in what we call a top-down, left-right methodology. So, we go from top down, and if you go into the category-specific rules, you see the breadcrumb trail there going from left to right. But this is, a way that we apply the rules in general. And again, the key point here is rules created in the advanced UI or legacy APIs are not visible in this simplified UI view. All right, so then looking at this is the whitelist blacklist connectivity ability in the environment. So, when you whitelist something, it creates the default deny rule, which is visible in the advanced UI, and it's created above the default rule section in the advanced UI. When you blacklist something, and here's kind of going through this showing you the two different ways that switch gets flipped. The blacklist actually creates the default allow rule, which is visible in the advanced UI, and it's created above the default rule section in the advanced UI. So, and then obviously if you choose none, you're going to use whatever the existing rules are or other rules that are in there. All right, let's give this a whirl. I'm cheating. This is a pre-canned demo where we can look at how a layer 7 app ID rule is set up. So he goes into the infrastructure area. We have a application profile set up for shared services, so DNS, NTP, that kind of stuff. And we need to apply this to another application rule. So we're going to next look at the context profiles and edit our context profiles. And here's our NTP, DNS, Active Directory, the server, the various, which the context profile defines the service for that profile. And then we look at the groups for the existing application. Those are the members of that existing application group. And then the new group we're going to set up is the one above it for HRM. And we're going to look at these memberships, based on either VM name or these, the one he's looking at now was based on tags. So the criteria for this membership is tag based. Then we go back to our distributed firewall, category specific, infrastructure. And we can add multiple sources into that initial rule. And then on the application side, where we create our layer 7 app ID rule, we're going to clone the rule for our new application, give it a name, reset the services to the new application based on those tags and machine names that we set up before. And we publish the rule, and the new application is secured.
Like magic.
Magic. All right, troubleshooting. Give me 1 second here. We're doing on time. All right. So for troubleshooting, I'm a little disappointed that last week the Network Insight talk on vBrownBag had to get rescheduled. But so I'm gonna go into that a little bit here. So for those not familiar, you should see this on the screen there. This is the vRealize Network Insight front page.
We see.
So vRealize Network Insight is a standalone product that VMware has, but it is also sort of a add-on bonus content, amazing sister app to NSX. A lot of the value that Network Insight has is paired with products like NSX. And especially for troubleshooting, there really isn't a better tool for troubleshooting NSX. Right off the get-go on the very beginning of the page, under the open problem section, we're going to call out, any, issues and environments that are, causing problems in the environment, including, NSX system events. And then in addition to that, we can still dive into, other, specific events, that are happening throughout your entire network. Or if we want to just look at, NSX events specifically, we can dive into that, and we will, this is our internal demo environment. So there's going to be all kinds of stuff in here. So I really can't pick out anything specific. But if I've been in customer environments where they had firewall rules in the distributed firewall policy that were conflicting with each other, and right on the main page, Network Insight was calling that out as an issue, and it even will give resolution suggestions for those issues that it detects in the environment. So this is an amazing tool, and if you're an NSX Enterprise Plus customer, you get Network Insight. So if you have NSX Enterprise Plus, you own Network Insight. So make sure you're using it, and make sure it's up to date, because there's always new stuff coming out for it. The other thing I want to quick show for this is, in terms of building a security policy, the way we, recommend customers build security policy in NSX is with Network Insight. So, to do security planning for an application, it's really just as easy as what I just did. Once your applications are built in Network Insight, we can see what they do. And, it gives you this nice little graph of, where traffic is flowing between what and where. We click into one part of the application and we say, we want to build security firewall policy, microsegmentation policies for that application zone in and of itself. How do we do that? Well, right at the top, it kicks out these recommended firewall rules. And we can take and say, these are all the flows for that section of the application. We will take and grab those and export them out to a file that NSX can consume directly, and import them into NSX, and it'll create the policies based off of known traffic that it sees in your application, in production or in a test lab, or however you develop your policies. And it essentially gives you a known good state to work off of, so you're not having to necessarily guess what your application's doing. You can say, this is what's actually happening, and we can validate this traffic, or or invalidate it, to know in the future if something changed, with the app and how it's performing, or what's going on with it. We can see that. So, this is my 60-second demo of Network Insight, and kind of how, we use this for customers to, plan their applications, plan their security, planning compliance for different things you need compliance for, you know, showing how, workloads communicate. I mean, this is an extremely powerful app, and definitely keep a lookout for Matt Just's Network Insight demo on vBrownBag coming up.
And for those who are interested, that one will be coming up on May 13th. And just to note, your 60-second demo is more like 90 seconds, so I'm going to have to penalize you, Britton. Continue.
In the penalty box. All right. So basic, otherwise standard, firewall troubleshooting rules, still apply for NSX. So the DFW Rule Hit Count, is it a available way for you to obviously see, is my firewall rule getting hit? So if you don't happen to have Network Insight and you aren't able to, dive into a workload and see, if a rule is getting processed by Network Insight, which you can do, you can look inside of NSX and see, is this particular rule getting hit or not? So it's standard stuff people have been doing in firewalls for years. And of course, anybody who's ever had to troubleshoot a firewall is always the first question anybody ever asks is, have you looked at the logs? Because that's generally firewall troubleshooting 101 is you start digging through logs. And of course,
firewall troubleshooting 101 was just allow all traffic through. Is that not the case?
It depends on the crisis and the application.
Sure.
But, the circles I've been in, it's always been like, well, let me look at the logs and I'll get back to you. So, you can either, again, the logs are kept locally on each hypervisor, of course. If you really want to parse through that file, in a manual way. Otherwise, you can, of course, export these things out to a syslog like Virtualized Log Insight, or, your favorite syslog tool of choice. So for Dataplane Rule Realization Verification, those are two big words. And I actually have customers who do some custom APIs to do some of this, where, they, have a script that runs across their entire, range of hundreds of hosts, and it kicks back a report that says, these firewall policies, have been successfully or not successfully applied to a given workload. So there's, like with everything, and like I said at the beginning, there's 50 ways to do everything. I'm just trying to give you a couple, and try to highlight some of the stuff that you might see on an exam as well. And part of this rule realization command line tools that you're seeing here might be something you might see on the exam. They do like to get into some of that command line stuff on the exam. So
folks watching on YouTube, rewind a few seconds so you can get these.
Yeah, and then the syntax matters in that case as well. So same thing for KVM. We're going to pull that stuff out, and do it. You can do it, in the command line of the KVM host itself. Otherwise, Network Insight or some other tool is your best friend. Okay, getting through it here. Context-aware firewall. So this is more of that layer 7 app ID stuff. We have a built-in list of apps that are supported, the same as we did in NSX for vSphere. However, in NSX V, we support sub-attributes of TLS, but in NSX T, we now also support sub-attributes for CIFS and cipher suites and for TLS as well. This can be used in combination, again, with RDSH or identity-based firewalling, which was not available in NSX for vSphere. Oh, I forgot that little animation right there. So use cases. So here we're allowing blast protocol, over port 22443, and then we can block RDP going over that same port. Here it's about blocking based on application protocol version, as well, for, TLS 1.2 is allowed, but not 1.1. And 1.0 was blocked. And we're also making sure that we block apps irrespective of the ports used. So port and app ID based enforcement. This is a breakdown of different layers of the distributed firewall rule application, what it looks like. And here we can do, either a rule based on just layer 4, a rule based on layer 4 and layer 7, or layer 7 only. It all depends on your granularity level of requirements in your environment. So the L7 app ID rules would be a really great way to restrict traffic based on known good protocols. You can filter out traffic from weak applications with compromised old versions of SSL or TLS or SMB or CIFS. And we apply those to specific apps or globally to protect everything. That's why they talk about how you can do kind of guardrail rules to disallow specific unsecured older protocols in your environment with this. All right, I'm going to try and talk my way through this. This is a challenging couple of slides here. So the data path inspection engine, or the VDPI you see here, we send the DFW rules down to the vSIP, and then that comes out and is inspected at the VMware SFW stores and the DFW rules and the connection table and context table, per logical port. The VDPI inspects that packet at layer 7, returns it back to the vSIP through the DV filter user. Oh, there it is. Okay. And the DV filter is data path that is used to exchange packets between VDPI and vSIP. So on a packet flow, so the new flow is initiated from the client VM. We check the flow table, and if there's no match in the flow table, so then we check the rule table. If the packet matches a rule with layer 7 app ID in the context profile, an entry gets put into the flow table, and then the packet is punted to the VDPI engine and released to destination. The DPI engine works out the app ID info and updates the context table. A maximum of 10 packets for the flow are punted to the DPI engine to support determining app ID. That's how we achieve our line rate performance. The VDPI can determine app ID based on usually based on the first packet. VDPI determines the app ID. The VDPI programs the app ID mapping to flow into the context table. This maps a flow to an app ID. In the next packet, we don't punt the DPI. We compare the context table and the flow table, and we compare with the rule table. So once it's matched, then the remaining packets for that flow are matched against the connection table in the kernel, checking against the flow table. And then we're just going. So some considerations: the layer 7 app ID, is not supported on or in the gateway bridge or firewall, KVM, bare metal servers, NSX Cloud, the CNI plugin, or redirection rules. A little bit of comparison with the NSXV and NSX T. I think the main things to note, are the different application versions that we didn't support before or cover before, and some of the context profile differences. Distributed firewall advanced functions for URL whitelisting. So for FQDN whitelisting, this is where we have, specific domains on the internet or specific cloud services that workloads need to connect to, and we want to allow or deny based on, those specific destinations. So we use DNS snooping to map the FQDN to the IP. Today there is no category capability where we're going to say, business services or sports services or whatever. Those are coming in future releases. Today in NSX T 2.4 and 2.5, we have support of, out of the box pre-canned list of URLs. Again, this is expanding to offer even custom URLs in future releases. And built into 2.4 and 2.5, there's not support for service classification for these third-party URLs or reputation-based services, but that's also coming in future versions. So for this, we're looking at the same architecture as the Layer 7 firewall, where we use the VDPI engine for URL deep packet inspection, and on top of that we use the DNS snooping to map the IP to the FQDN. And the interesting piece of this is that it does support, it does work still with vMotion, so the FQDN context moves with the machine. So in the workflow, we start off initiating a DNS request for say Office 365. DNS request matches, in the Layer 7 DNS rule. DNS request is punted to the VDPI engine and released to the destination. DNS response matches the connection table entry, and then the DPI extracts the IP and FQDN from DNS response. The VDPI program is mapping to the data plane. The enforcement workflow, we do an HTTP GET for Office 365, initiated from the client VM. The destination IP is matched against the IP FQDN table in the data plane. The connection entry then gets added into the connection table. Packet is sent to the destination, and subsequent packets for this flow are evaluated based on the connection table. So same real architecture that we use for most everything else. And again, some considerations. We only really work on ESXi. So the other hypervisors, bare metal servers, those things, we will not have this as of yet. Identity firewall. Any other questions, Ken?
There's one that's kind of off topic. I'm going to save it for the end.
All right. I'm still going to ask because it gives me a second to, take a drink.
Sure. I'll spit it out while you take a pause. So Edwin was wondering if during the series you'll be covering the differences between NSX T Data Center and NSX T for VMC on AWS.
Oh, no.
That was easy. No.
I'm going to punt on that one. There are subtle differences, and I have not dived into the VMC side all that much yet. I know there are differences, and that's enough that I will say about that. So, back to the identity-based firewall. This to me was one of when I first saw NSX for vSphere, the identity firewalling capability that it had. In my opinion, as small as I might be, I thought that this was the most underutilized service in NSX for vSphere, because the very first production deployment that I did for my employer back in the day of NSX for vSphere, we did turn this on, and I could, if I had a set of user desktops, with their gateway and security policies and everything happening inside of an NSX network, I could turn on the identity-based firewall, and these are not VDI devices, these are desktop devices, and I could make, the whole data center disappear from the user's view based on who the user was. And that for some reason that identity firewalling capability never really got a lot of attention or took off all that much. But we're kind of, I'm glad it's still here, and I'm glad we're kind of doubling down on it, because the capability of, somebody compromising an account based on a user, who has access to a VDI to get into your data center, pretty high. And so being able to say, X user of a virtual desktop, can't get to anything else outside of one of these subnets or one of these networks, or one of these clusters for that matter, is a really powerful thing to do for your environments. And this is especially true today, in today's medical environments, where we have hospitals who run all of their workstations in VDI, and unfortunately, threat actors are constantly attacking medical centers and hospitals, and bringing them virtually to their knees and not being able to support patients because of things like virtual desktops being compromised. So that's where NSX on top of VDI really can help avoid those scenarios. So feature use cases for VDI, again, we cover VDI, be it VMware Horizon, Citrix, or Microsoft Remote Desktop session hosts. In this example, the VDI system controls the user access to the virtual machine, and then after that part is done, we control the NSX security policy from the virtual machine to the applications and the rest of your network in that case as well. So it's really a split security model where the VDI system does what it does to get the user into the machine, and then we do what we do to secure everything else. In the RDSH example, we control access, once the RDSH to apps, using the ID firewall policy. So, I think this is again based on, Active Directory groups. So, the Active Directory group here, allows access to this remote desktop session, and then, it'll either allow access to the app or it won't based on, Active Directory. And then we will enforce that policy based on Active Directory group membership.
And I noticed you say it says they're only MSAD, so no like LDAP.
Correct. Yeah, we'll actually directly integrate NSX Manager with Active Directory for this particular firewalling capability.
Cool.
So the other pieces that are required for this, is VMware Tools version 10.3 or later. This is probably one of the main things we see in customer environments where people deploy VMs and they install tools once and then they never update them. This is really should be part of your patching strategy across your environments everywhere. This is just good security strategy. Make sure your VMware tools are up to date, because then you can take advantage of new things like this with NSX when they come along. Otherwise, it's just good patching policy.
I think you just made Bob Plankers very proud.
I know. I didn't want to invoke Bob, but I'm glad you did.
There you go.
On the guest and host operating system side, as NSX advances, these operating systems are going to advance as well. So that's why you're not seeing, like Server 2019 in here and some other newer things. But, again, the key points here are Active Directory only, and update your VMware tools. So we used to use this methodology of log scraping, which is not supported currently in NSX T, or not supported anymore. So there was some customers who, even on a VDI base, where they did not have tools installed in a machine, they would use log scraping to do identity firewalling. So in those environments, if you're a VDI shop, but you don't have VMware tools installed, the recommendation is install VMware tools so that you can get that enforcement. All right, I got to start flying through some of this stuff here. I want to get to some other stuff before I run out of time.
If it's enough material and you want to schedule another session, by all means, we can do that.
Yeah, I think we'll get through it here. NSXT, NSXV. Okay, so people can pause this slide and look at it if they really want to look NSXV versus NSXT. Guest introspection. This is again where we come in with agentless antivirus and agentless anti-malware in the environment. So guest introspection is what allows customers to deploy the trend micros of the world, deep security and things like that into their environments and apply distributed security policies across VDI or other workloads. So the big deal here is guest introspection. Before the move to 2.4, 2.5 is there was a separate service that fills this blank box here called the GISVM, and that machine was deployed to each node, and now we've pushed that into the kernel. So it's, we've sort of flattened the footprint, as it were, of how we can do guest introspection in NSXT. And this makes things a lot, more streamlined and gives partners as well a lot more flexibility in their deployment, where the partner machine doesn't have to be, one size fits all. It can be a different size based on different size workloads. All right, this is basically where I wanted to wrap up. So bare metal security, microsegmentation for physical backed workloads. And I wanted to get to this here because this is one of the, key new use cases for NSXT is the ability to connect into these, physical VLAN backed or overlay backed workloads. Protecting physical workloads outside of, the virtualization domain of vSphere, is a critical security play that we need to be able to control. And we can do, bare metal connectivity with VLAN backed workloads, or overlay backed workloads, in a physical world as well, where, they're connected on the same overlay logical switch. We also have the ability, these additional use cases for virtual to physical or physical to virtual microsegmentation, where we can stand up a stateful layer 4 firewall with the Open vSwitch based NSX enforcement running inside the physical endpoint. And again, we'll also can do the physical to physical microsegmentation with stateful layer 4 firewalling, OVS based NSX agent inside the physical endpoint. And those are in 2.4, 2.5, those are primarily all Linux based in physical nodes that would come under controls in NSXT fabric node type. But again, in NSXT 3.0, we're moving into Windows Server 2016 as a supported operating system. So if you have physical workloads that you want to do this bare metal connectivity and security for, NSXT 3.0 has you covered there now as well. So how it works, the application, application running on the bare metal server, either web server, a DB server, whatever it is, we stand up an application interface, and that represents the NIC to which the application uses for sending and receiving traffic. And then we also stand up, sort of a vSwitch in the physical box itself that represents the NIC by which the bare metal is managed. And then the virtual interface is the pure application interface, which is attached to the logical switch. So that's how the application gets its connectivity. So we stand up this, software service inside the bare metal server. And that software service, effectively gives us full network management and control of that bare metal workload. And this is, pretty cool stuff the way you see this. So if you have, those legacy applications out there that you can, that you have the ability to move this stuff into, NSXT for security, this is an option for customers. The bare metal server modes supported, we can do, VLAN overlay or, underlay 0 VLAN 0 mode, where it's just a, single NIC connected in. But again, where we're trying to give customers as many options as possible for connecting, and securing all workloads across the environment. And with that, I'm going to wrap it up.
All right. I'm looking in the Q&A right now. I don't see any asking questions. If you guys have any questions, feel free to ask them now. And while people are getting those questions in, I'm just going to remind folks this will be up on our YouTube channel in the next day or two. If there are slides that you may have missed because you joined late or we were running through them quickly at the end there, check out the YouTube channel, vBrownBag, pretty easy to find, and watch this or any of the other videos in the series to get caught up. All right. Let's see if there's anything in the Q&A. Nothing right now, so I'm just going to say Q&A going once, going twice. Before I say gone, thank you very much, Britton. Really appreciate you doing the series for us. We'll see you folks next time, and no questions in the Q&A, so I think we'll call it a night and say goodbye.
All right, thanks again.
Thanks, Britton.